Hey guys, this is Jackie. Hope you're doing good. This video tutorial, I'm going to help you how to solve this question. Okay, this is question one of the tutorial assignment one, and this is question A. Okay, so the question asks you to find all reactions and then find N, V, and M at B. Okay, B is right here. Okay, around the corner, and you can see that this B negative and B plus. B negative means you cut from this section and consider from the cut to the left, and B plus means from the cut here to the right. I'll show you in a moment. Okay, so now first we have to find reactions. Now we can see this is hinge support, so we're going to put vertical reaction we call VA, and horizontal reaction this is going to the right, so I put this one go to the left, so I call this one is HA. Okay, now at the is the roller support, so only one reaction vertically. Okay, so VD. Now as we can also see that this is UDL, right? So I will make a resultant force at right at the center of this UDL. Okay, so this is gonna be 1.5 times 1.5 here times the length, gonna be 8 meters. So 1.5 times 8 equal to 12 kilonewton, right? Okay, so before I find reactions, I will assume the positive sides. Okay, I always assume go to the right gonna be positive, go up gonna be positive, and clockwise gonna be positive. Okay, it's up to you. This is my way of convention. Okay, so now we look here. So to find reactions for this whole structure, we're gonna find by using sigma fx, sigma fy, and sigma moment. So now have a look here first. We see that we have 5 kilonewton and HA. These two forces are in horizontal, which is in x direction, right? So we're gonna, and this is null force, this is unknown force, so we can solve this one easily. Now I will take sigma fx equal to 0. Excuse me. Now 5 kilonewton to the right, same as this way, so positive 5. So 5, and then HA to the left, so negative HA, and then that's it, equal to 0. So therefore HA equal to 5 kilonewton, and you see that is positive 5, right? So it means that HA gonna be same as our first assumption of direction. Okay, so still to the left. Okay, so I'll put 5 here. Okay, equal to 5. Now next we gotta find see here we left with 2 unknowns, right? So to me I will take sigma moment here. Okay, the reason why I take this moment here is because this force and this force will cancel out. Okay, so we're left with this one unknown, this one unknown, and one unknown here, so we can be able to solve this one. Okay, now I will take sigma moment at A equal to 0. Okay, now this cancel, so this one 5 kilonewton. Okay, because 5 go around A here, we go around clockwise direction, so positive. Okay, positive 5 times, okay, the length from from this force to A will be 6 meter here, okay, 6. Now, next will be 12. Okay, 12, now point A here, 12 goes around and clockwise A, okay, see, clockwise A. And this gonna, so therefore we're gonna be positive, okay, positive 12 times, now 12 times the distance from 12 goes straight here, so distance from 12 to A gonna be 8 meter. Sorry, 4 meter, half of 8 meter, okay? 4 meter, so 4 meter, right? So 12 times 4 equal to, no, sorry, one more, just delete it. Okay, now 12 and then VD here, okay, VD. So because VD goes anti-clockwise around A, see, go anti-clockwise around A. So negative VD times the lever arm from VD to A gonna be 8 meter and 8 meter, so 16 meter. 16 meter equal to 0. Okay, so I rearrange and I find VD. Okay, VD I have here will be 4.875 kilonewton, and this is because this is positive, so our first assumption upward gonna be upward, same. Okay, so I put here gonna be 4.875. Okay, so we left with VA. So easy, right? So we already take sigma fx, sigma moment, and now we take sigma fy. Okay, now we'll take sigma fy here. Sigma fy equal to 0. We have this vertical, this vertically, and this vertical. So 3 forces in vertical direction. So put it in. This is VA upward, right? So VA positive, okay, positive VA, then negative 12, then positive VD, right, which is 4.875 equal to 0. So therefore I rearrange, I have VA equal to 7.125 kilonewton, and this is positive again, so our first assumption upward going to be the same, so upward. Okay, if you don't write down the direction of the force, you will lose amount. Okay, now that's the first part of the question. Now next one, they ask you to find NVM at B. Okay, you see here B, we have B negative and B positive. So B positive from this one to the right, and B negative from this one, from this cut, go down. This. Okay, so now let me show you. So I will take a cut. I make a cut here. Okay, for B negative, I make a cut right here. I make a cut just right here. Okay, so I consider from this point, from this cut, just about the point, just before the point B. Okay, just before it, from here, from the cut to A. Okay, so I draw it right here. So this is B negative. Okay, so now we have this and that one. This was this is 7.125 we saw before, we have had it before. Okay, 7.125 here, 7.125. okay, so that's why I put 7.125 here, and 5 to the left, 5. Okay, this is A. Okay, now we make cut right here, and this still 6 meter. See here, you can see here 6 meter, right? So it's 6 meter, because we just cut just about point B. Now I have a question. Should we put 5 kilonewton into this section? The answer is no. Okay, because we just cut just before the point. Okay, so therefore we don't consider this one. Okay, just before, from here to here, there's no 5 kilonewton here, right? See, so therefore ignore this. Right. Okay, now we're gonna put NVM into the cut here. Okay, so I'll change the color for you. Okay, now N is something that goes straight to the section. So N, okay, so N always, so go in or go out, doesn't matter, as long as it's go straight to the section. Now next gonna be V. Okay, V always sliding on the cut or 90 degree with the section, with the structure. So V is V. Okay, so V is V, right? So 90 degree, you see, 90 degree with the structure here. Okay, so it can be to the right or left, doesn't matter, up to you. Okay, this is our assumption. Now, right now, last one gonna be M. I'll put this M this way, okay, or you can put this way, up to you. Okay, now we have everything we need. So now we're gonna find V, we're gonna find N and M. Okay, again we're gonna find these three forces by taking sigma fx, sigma fy, and sigma moment. Okay, now you can see, now to me I will do sigma fx first, because this one and this one in x and this unknown is unknown, so we can easily get V. So I will take sigma fx equal to 0. Okay, so we have V to the right. Okay, so I'll take a positive V and negative 5, so equal to 0. Therefore V equal to 5 kilonewton, and it's a positive, so our assumption is correct. So positive, go to the right. Okay, now next we have this one and that one in vertically, okay, in vertical direction. So this is unknown, this is known, so okay, we can get this one. So I'll take sigma fy equal to 0. Now we have n go down, so our assumption down is negative. So negative. So down is negative n, and positive, this is upright, so positive 7.125 equal to 0. So therefore n equal to 7.125 kilonewton. Okay, so this is positive, so our first assumption is correct, so let's go down. Okay, now last one, moment, right? I will take sigma moment. Where about? I will take here, because if I take moment here, this will be cancelled out, this will be cancelled out. So we're left with this one and this one, right? So I'll take sigma at cut equal to 0. Okay, now now cut here, right? This cancel, so that one around the cut here, the point here, 5 kilonewton go clockwise, right? Goes clockwise. So positive 5 times distance gonna be 6 meter times 6 meter. Okay, from the force to the point, 6 meter. Okay, so and this one, okay, so this one gonna be cancelled out as well. Sorry, this one cancelled out because this goes straight to the point, so this is 0. So That's cancel, that's cancel, that's cancel. So only this one. So good. Now moment. Now if moment go anti-clockwise, right? So negative moment equal to 0. Therefore, moment equal to 30 kilonewton meter. And it's a positive again, so our first assumption is correct. This way. Okay. That's it for B negative section. Okay. So we do the same thing for B positive, which is from here, from just after the point B, from here, from the cut here to D. Right, now we do it. Okay, change the color again. Okay, just write down here B positive. Now how it looks like now. I'll just scroll down. Okay, it looks like this. Okay, now that this and roller support here, UDL here. Okay, UDL, 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 and resultant force we calculated before, which is 12 kilonewton. This we have 4.875, okay, kilonewton, and the distance gonna be the same. Okay, so gonna be 8 meter, 8 meter. Okay, now we make cuts here, right? This is the cut. You can see here. This is the cut here, right? Now again, we're gonna put NVM to the cut. So I'll change the color again. Okay, now we have again N goes in and or out, up to you. Okay, I choose in. Now V gonna be sliding on the cut or perp 90 degree with the section, with the structure here. Okay, so I'll choose V here, up. I choose V, up, V. Okay, and moment. Okay, I'll choose this way, this direction. Up to you. You can choose another way. Okay, now ready. We have excuse me. Okay, now we can see again we use sigma fx, sigma fy, and sigma moment to solve these three forces. Okay, so we can see there's only one force, which is n here, only one force in x direction, so this itself is going to be equal to 0. So sigma fx equal to 0 and only n, so equal to 0. Okay, now for V, we have V in vertical, right? Vertical and vertical, so three forces, one unknown, which is V here, so we take sigma fy. Sigma fy equal to 0. We can solve V. Okay, so we have V positive because up, so V. Now 12 go down, so negative 12, and this one up, so positive 4.875 equal to 0. So therefore we rearrange, we find V equal to, I already calculated here, so I have 7.125 kilonewton, and this is positive, so same as our assumption, so which is upward, right? Okay, now last one gonna be M. I'll take sigma moment at somewhere, so which point? Again, out to me, I will take this point, because this one cancel, we have this one and that one, and moment unknown, so we can find moment, right? So I'll take moment at cut equal to 0. Okay, now what we have 12 here. Okay, so 12 times distance from the force to the point, which is 4 meter, half of 8 meter. Okay, so 12 goes around and clockwise point the cut here, so positive 12 times 4 meter. Okay, and this one 4.875. So and this is go around the point here, but anti-clockwise, so it's gonna be negative. Okay, negative 4.875 times distance from the post here to the point, which is from here to here, right? So from here to here, which is 8 meter and 8 meter, which is 16 meter. Okay, and this one moment clockwise, so positive moment equals 0. Now, and then now you calculate this and rearrange. You got m equal to, I have this one, m equal to 30 kilonewton meter, and this is positive, so same as our assumption, which is clockwise. Okay, now that's it. Now I have solved this moment Vn for B plus. Okay, and then I already calculated M and V for B negative, and I also calculated VA, VD, and HA. Okay, reactions. Okay, so everything is done. Okay, so see you next video for the next question. Okay, see ya.